Now reduction of the general equation to the perpendicular or so called normal form. Okay. Now to reduce the general equation, and the general equation is ax plus by plus c is equal to 0. Now let it be equation 1. To perpendicular form or normal form, that is x cos alpha plus y sin alpha is equal to p. Let this be equation 2. Okay. Now supposing both are supposing equation 1 and equation 2 represents same straight line, represents same straight line, then what we can write it now? We are just solving these two equations. Okay. So we will be having then a upon cos alpha is equal to b upon sin alpha is equal to c upon negative of p. Okay. Now from here what we are having from here we will be having now cos alpha is equal to negative of ap upon c and sin alpha is equal to negative of bp upon c. Now squaring and adding, what we are having? Cos square alpha plus sin square alpha is equal to a square p square upon c square plus b square p square upon c square. Okay. Now this becomes p square upon c square taking common, and where a square plus b square is equal to 1. Okay. Sin square alpha plus cos square alpha is 1. The identity we have used it. Now here p square is equal to c square upon a square plus b square, or p is equal to plus minus c upon square root of a square plus b square. Up to here we got the value for p. Now two cases arises. Okay. Now number 1. Okay, let's write here. Now case 1. Now in case 1 we will be taking positive of c because we are having two values of c, positive and negative. So case 1, when c is positive. Okay. Now remember one thing, when c is positive, p is always positive. Okay. When c is positive, p will be considered as positive only. Okay. So we are having p is equal to c upon square root of a square plus b square. Now we are getting cos alpha as negative of a upon square root of a square plus b square. Now cos alpha, here it was negative of ap upon c. In place of p, now we have put c upon under the root a square plus b square, then c and c cancels and we are left with negative of a upon under the root a square plus b square, and sin alpha is equal to negative of b upon square root of a square plus b square. Okay. Now equation 2 reduces to, equation 2 is this one. Okay. Now we are putting value of cos alpha and sin alpha in this equation. Okay. So equation 2 reduces to negative of a upon square root of a square plus b square with x, negative of b upon square root of a square plus b square with y is equal to c upon square root of a square plus b square, which is the required equation in general form. Okay. So this equation x cos alpha plus y sin alpha is equal to p, when written in general form it will be negative of a upon under the root a square plus b square with x, negative of b with y upon square root of a square plus b square is equal to c positive upon a square plus b square. Now case 2. Case 2, when c is negative, p is always positive. Okay. Now here p is equal to negative of c upon a square plus b square. Now here cos alpha, this becomes now a upon square root of a square plus b square, and sin alpha becomes b upon square root of a square plus b square. Okay. Now again equation 2 reduces to a upon square root of a square plus b square, x positive of b a square plus b square, y is equal to, now we are having negative of c upon a square plus b square, which is the required equation in general form. So this is the reduction of a normal equation into general equation. So what is first thing? We got this one, when case 1 when c is positive, and here this becomes this one when c is negative.